And today I'm talking to you about opportunities ahead for young microbiologists. The opportunities that lie ahead for young microbiologists is what we are looking at in this talk today. The present realities and the future pathways. If this is your first time on this YouTube channel, please subscribe, like, and share the link of this video with your families and with your friends. The microbial world is tiny in size, but it is enormous in impact. As a field, as a field, microbiology sits at the crossroads of health, environment, industry, and technology. For young scientists just starting out, this is a landscape rich with opportunity, driven by urgent global challenges and rapid advances in tools and methods. In this video, I am going to be sharing with you a practical, forward-looking perspective designed to inspire and guide you. Current landscape where microbiologists are making a difference. Number one is human health and medicine. Microbiologists are central to understanding the human microbiome, infectious diseases, antimicrobial resistance, and vaccine development. From bench research to clinical diagnostics, microbiology informs strategies that improve patient outcomes and also public health. Now, in the terms of current landscape, where microbiologists are making a difference, another area is in environmental stewardship. Microbes drive nutrient cycling, pollution cleanup, and climate-related processes. Studying microbial communities helps monitor ecosystems, optimize wastewater treatment, and explore bioremediation solutions. Apart from these, microbiology presently also work in areas like industrial and food sectors. Microbial processes enable fermentation, bioproducts, and quality control in food and beverage production, pharmaceuticals, and bio-based materials. This intersection of biology and engineering creates roles in process development, quality assurance, and product innovation. We also have the impact of microbiologists presently in the area of biotechnology. Biotechnology and data science are another area that microbiologists currently are involved. And this, what they do in this area is they work on genomics and metagenomics. And this is because of the rise of genomics, metagenomics, and systems biology. And this has amplified the need for skilled microbiologists who can design experiments, analyze complex data, and translate findings into practical applications. So this is an area that microbiologists find themselves, and they are really working in that area. Now, we have looked at what is happening currently in terms of microbiology. We want to move on to look at the future opportunities to watch out for as a microbiologist, as a young microbiologist, as an old microbiologist, as a microbiologist that is just coming up. What are the future opportunities to watch out for? Number one of these future opportunities is precision microbiology and personalized medicine. As sequencing becomes cheaper and faster, sequencing used to be very expensive previously, but today it is cheaper. Today it is faster. That when you place the sequencing sample in the next 1 hour, it can be ready. And usually you place the sample at the facility, by evening, the result will have been sent to your email. So as sequencing becomes cheaper and faster, clinicians and researchers will tailor diagnostics and therapies to an individual's microbial profile. Expect roles in genomic counseling, microbiome-based therapeutics, and targeted modulation of microbial communities. Apart from this, we also have synthetic biology and designer microbes. This is all part of the future of microbiology. Engineering microbes to produce biofuels, pharmaceuticals, and sustainable chemicals will expand, with attention to safety ethics and regulatory compliance. Careers will span strain development, bioprocess optimization, and product commercialization. Apart from this, in terms of future of microbiology, we also have microbiome-centered agriculture. Microbes that promote soil health, plant growth, and disease resistance will transform farming. Opportunities exist in agri-genomics, biostimulants development, and field analytics to optimize yields with reduced chemical inputs. All these are part of the future of microbiology. Another one which is part of the future of microbiology, which you can key into, is urban microbiology and public health. Urban microbiology and public health infrastructure. In this case, that involves building resilient cities, which include monitoring indoor air quality, water systems, and food supply chain. While we talk about indoor air quality, you know that indoor air quality compared with outdoor air quality, there is more attention to indoor air quality. Why? Because the rate of dilution is low. When it is outdoor air, the rate of dilution is high. So whatever is the harmful substance in the air outdoor, it can easily be diluted. But indoor, dilution is difficult. The rate of dilution is low. So attention is moving toward this area. So if you are looking at going into some areas of microbiology, these are some of the things you'll be looking at. Don't focus your attention on the past of microbiology. Be looking at the future of microbiology, where the advanced countries already are. That is where the developing countries are going to be shifting towards. So that is what I'm talking about: indoor air quality monitoring, water systems, and food supply chains. When we talk about all these chains, water monitoring, water surveillance, food supply chain, the surveillance. So the surveillance means from the start of the supply chain to the end of the supply chain, you don't know where a pathogen got involved. So that is why you have to monitor everything in the supply chain, and that is what the concept of surveillance is all about. Microbiologists will contribute to risk assessment, outbreak response, and biosurveillance networks. Now, apart from this, part of the future of microbiology is that computational and systems microbiology is another one. In this case, big data, machine learning, and modeling will enable deeper understanding of microbial ecosystems. So the roles of microbiologists in these places include algorithm development, predictive modeling, and integration of multi-omics datasets. All these are part of bioinformatics. And I've said it before, if you are a young microbiologist, why don't you focus on this area of bioinformatics? Why don't you queue into this area of bioinformatics? You can self-teach and then develop it later. Don't wait for anybody to teach you bioinformatics and be saying that in our school they didn't teach about bioinformatics. You can self-teach. A lot of materials are online that can help you to get started. Then from there, you can shoot and move on in that area and get perfect with one or two certifications. So as I said, roles include algorithm development, predictive modeling, and integration of multi-omics data sets. Apart from this, another feature of microbiology is global health and neglected diseases. Global health and neglected diseases. Persistent health disparities create demand for researchers who can study pathogens, vaccines, strategies, and microbiology-enabled diagnostics in low-resource settings. And this is where the work of a microbiology comes in. Apart from this, part of the future of microbiology is policy, ethics, and science. Policy, ethics, and science communication. As microbiology intersects with safety regulation and public perception, skilled communicators and the policy specialists will help translate science to society and shape responsible innovation. The microbiologists must find a way to make friends with the politician. Like my mentor and my supervisor will say, there is no solution without political solution. Yeah, thank you. Thank you. I can see a comment here from Adetitun or thereabout. Thank you very much for your comment, saying well done. Yeah, well done too for stopping by to watch and to listen in. So I'm talking about policy ethics and science communication, and we are seeing how microbiologists are going to shape the future in that area. Now, I went on to talk about there is no solution without political solution. The microbiologists must find a way to synergize with the politicians because they are the one that will, no matter the research output of the microbiologists, the politicians are the one that will rubber stamp it and make it to become a policy. So they must find a way to be able to pass their research to these politicians and let them be able to do what they need to do. Now, if you are going to be relevant in the future of microbiology, what are the skills you need to develop for your future success? Number one skill is strong fundamentals. You have to master the core microbiology concept, microbial physiology, microbial genetics, ecology, host-mite interactions, and a host of others. A solid base makes it easier to adapt to new subfields. Like I was saying now that you should move into bioinformatics. Now you are already grounded in the basic microbiology. You are not a novice in basic microbiology. I'm now saying you can move into bioinformatics. So if you're going to prepare for the future in microbiology, you must understand the basics of microbiology so that you can now move on. Another skill to develop for future success is hands-on lab proficiency. Experiment design. You must know how to design an experiment. Then sterile technique, data collection, and meticulous record keeping remain essential. I tell students in my lab, I've learned this when I was doing my own program. You have to have a lab note. How can you say you're a student working in the lab? You don't have a lab note. You have to have a lab note. Everything you want to do, your materials and method that you want to use in the lab must be written in your lab note. Then, as you are doing it, what you do per day, write your lab note. The result you get, write in your lab note, enter it into the system. And even before you complete, if you are going on an experiment of day for 20 days and you are measuring the parameter daily, every day you are inputting into the system and you are trying to see where the graph is going already. So as you put it in, the graph is extended. As you put it in, the graph is extended. So already you are preparing, you are moving, you are anticipating, and then you are really, really involved in the research. So another skill to develop for future success as a microbiologist is hands-on laboratory proficiency. Experiment design, sterile technique, data collection, and meticulous record keeping remain essential. If you don't keep record very well and you lose your record, what are you going to say happened? That means you wasted all the time. So you have to keep record as a microbiologist very well. Apart from this, proficiency with modern platforms like next generation sequencing, flow cytometry, mass spectrometry is increasingly valuable. In some labs, before they host you in some lab, maybe you want to work in some labs abroad or in some places, they ask you what you can do, because maybe that is the area they want you to be able to do when you come to their lab. That's the area they want you to come and help them with. So you are coming with added value. And then all these things are preparatory. Apart from this, another area that you need to, another skill you need to prepare for the future as a microbiologist is genomics and bioinformatics literacy. The importance of this bioinformatics literacy cannot be overemphasized. And I'm challenging you, self-teach. Take a course in bioinformatics. Take a course in all these things, and before you know it, you are going to get to know them well. So you have to learn to analyze sequencing data, work with public databases, and use statistical tools. Familiarity with Python or R and basic data visualization pays big dividends. So you have to familiarize yourself with basic data visualization. It's going to help you anywhere you are. You are going to be an asset anywhere you find yourself. Now, apart from this, another skill you need to hold on to as a microbiologist for the future is interdisciplinary fluency. Interdisciplinary fluency. Many roles require collaboration with chemists, engineers, clinicians, and data scientists. So you have to develop the ability to translate microbiology concepts into cross-disciplinary language, and this is another thing you need to do. Most of the work I've done so far are with chemists. Personally, I am working on bioremediation of petroleum contamination. Now, these petroleum contaminants are chemicals. So I work with the chemist so that I can be able to understand the chemicals you're trying to degrade properly. So while I'm bringing my own microbiology knowledge, they're also bringing their chemistry knowledge, and then we can align together and work together. Most of the chemical compounds that are being degraded by microbes are chemicals, and then these chemicals are best understood by the chemist. So you can see you have to work in the multidisciplinary environment. Sometimes also I do some work where some chemists develop some drugs. They work with drug discovery, and then when they develop the drug, I help them to analyze and check the biological properties of the drugs that they have developed. And that is that. I check the antibacterial property here and there, and then it makes their work also to be robust. It is not just good to just develop the drug as a chemist. You also have to go ahead and analyze the drug. Thank you very much for your comments. Adetitun, Blessing, Eniola, say well done, sir. And this is another individual, Kabu. Thank you. He's saying hi. Yeah, hi, both of you. Thank you for stopping by. And I hope you are going to be joining me every day like this. Every day on this channel around this time, or between this time and the 2 hours, I'm going to be online talking microbiology, just one subject, one insight like this per day. So you can join me. I am not very sure of the timing yet. So I don't want to give a time and then I'm not meeting up with the time. But every day I'm going to be live. So if you subscribe and you click on the notification button, anytime I'm live, you are going to be notified in your email. So communication and storytelling is another thing that microbiologists are involved in. Clear writing and persuasive presentation skills help you share findings with diverse audiences, from peers to policymakers. You can see what I've said. Now, microbiologists have formed the habit of just going to doing their research in the lab, going to a conference to present the paper, then write the article and publish it. The policymakers don't go to your journals or articles. So microbiologists must find a way to be able to make it to reach the policymakers, maybe by publishing it in a magazine, in a newspaper, maybe by creating a blog, maybe by doing something that will make the research you have done to reach policymakers, maybe by writing a communique or what your key findings are, write it as a letter to the policymakers so that they can be able to understand and grab what you are doing. Yeah, thank you very much, Eniola Ali. Thank you again, Eniola Ali. I can see you are saying hi. Hi also, Eniola Ali. Thank you for joining my live stream today, and I hope to see you often. Thank you for liking. Please like the video. When you like the video, YouTube make it known to other people that I am live now. So I'm talking about communication and storytelling. A microbiologist must be able to communicate. What you have found in the lab should not just end the lab, should not just end with your microbiology jargons, microbiology language, microbiology vocabulary. Be able to interpret it to the policymaker who is a lawyer, who is an economist, who is a businessman, but is in politics, who does not understand the nitty-gritty of microbiology, but you do, but you must be able to communicate with him so that he can understand, grasp of what you're saying, and be able to make your findings to become policy. So all these skills help you share findings with diverse audiences, from peers to policymakers. As I said, the other skill that a microbiologist must have for the future is ethical and regulatory awareness. Ethical and regulatory awareness. You have to understand biosafety, biosecurity, and regulatory landscapes. Responsible innovation is a competitive differentiation. Now, let me talk about the pathway to enter and to advance as a microbiologist. Pathways to enter and advance as a microbiologist. Number one, build a strong network. You need to build a strong network. You have to seek mentors, join professional societies, and participate in conferences and local lab groups. Networking often opens collaboration and funding opportunities. Apart from this, you have to gain practical knowledge or practical experience, and you have to seek internships in laboratories that you want to, like I'm talking about bioinformatics. There are some people that are very good in bioinformatics already. So what you need to do, they may be close to you or far away. You can seek and communicate with them that, wow, I want to come and learn bioinformatics from you. I want to come and know more about bioinformatics from you. Please allow me. If they say they don't have funding to bring to host you, tell them you can raise your own transport fare. You can raise your own plane ticket, and you can raise your own living expenses when you get there. And then you go there and then you learn. And then what you learn becomes part of you, and that's you gain practical experience. So seek internships, co-op placements, or summer research programs. Real-world lab work builds confidence, and it also builds your CV. Thank you for your comments. Owaslo, yeah, you're saying hi. Hi, Owaslo. Thank you for joining my live stream today. I appreciate you, and I hope to see more of you every day, because every day I'm going to be live, but the exact time I'm going to be live, I am not starting. But it will be around this time, this time today now is this 3:28. So by tomorrow, around that 3:28, 3:30, 3 o'clock, I'll be live again between 3 and 4, thereabout. I'm going to be live again. Now, you have to diversify your experiences. Alternate between wet lab work, data analysis, and field-based projects. Alternate between wet lab and dry lab. Don't just stay in wet lab alone. Move to dry lab, my friend. Move to dry lab. That is where things are happening today. So, but it involves learn a lot of things, and you have to use computer, this and that, a lot of things, computer programs, softwares here and there, but it is something you can do. So a varied portfolio shows adaptability, and it also shows resilience. Now, another thing you need to do is pursue targeted training. Pursue targeted training. Consider coursework or certificates in bioinformatics, data science, biosafety, or regulatory affairs, depending on your interests. So you have to consider coursework or certificates in bioinformatics or other areas of microbiology that interest you. So you have to pursue targeted knowledge. Don't just stay in one place and say, wow, I have BSc, I have MSc, I have PhD. That is all. No, that is not all. You have BSc, you're just starting. You have diploma in microbiology, you're just starting. You need to climb up. You have masters in microbiology, wow, that is good, but you need to do something more. You have PhD in microbiology, yes, that's great, but you still need to add to it. The current things are happening, you have to add to that. Now, apart from this, you have to embrace lifelong learning. Embrace lifelong learning, because knowledge is not static, knowledge is dynamic. Knowledge is in quantum, is moving, is not static. So the field evolves rapidly. Stay curious, update your skills, and be ready to pivot as new technologies emerge. Now, before I close, I'm going to give you a suggested plan for the next 12 to 24 months as somebody who is just coming up. I want to adapt, I want to do something tangible in this area of microbiology. As somebody who is looking at opportunities ahead for young microbiologists, as I've titled this live stream, the present reality and future pathways, I want to give you like a plan ahead, because you can't just listen to me. I'm talking about opportunities for microbiologists, and then you do not take action. You have to take action, because action takers are favored people. So I'm going to give you some suggested plan for the next 12 to 24 months, which will help you to advance as a microbiologist. I'm not just out to just talk and then we leave every talk there. I also have things I'm learning and I'm developing, because I want to help other people, so I also have to develop. Now, this is a suggested plan for the next 12 to 24 months for you that are watching me. Number one, clarify your interest. Clarify what you are interested in. That is the first thing you should do. Sorry, let me look at this. This individual says, excuse me, sir. My mom said I should go with my big sister to buy drinks for my little sister's birthday. Yeah, that's good. You have to obey your mom. Your mom said you should go and buy drinks for your little sister's birthday. Go ahead and buy the drinks. That's good. That's good. That's good. That's good. This video, this live stream is going to be recorded. So by this time, in 24 hours time, you can come back and watch it. It will have been downloaded and uploaded on YouTube, so you can come back and download all the live stream I'm going to be doing every day. If you cannot join the live, you can watch the uploaded one, which is going to be available. So I thank you very much for that. Let me see the name of the person saying this. This individual is I can't get the name properly. Thank you for that. And yes, you have to obey your mom. So go and buy the biscuit and whatever you want to buy for your sister's birthday. So a success plan for the next 12 to 24 months for you. Clarify your interest. Identify whether you are drawn to health, environment, industry, or a cross-disciplinary path. Write a short personal mission statement. So you write it down. That is going to help you. Apart from this, get hands-on experience. Join a research group. Contribute to a project or complete a micro internship. Aim to produce a tangible output, a poster, a data set, or a manuscript draft. Then the next thing you need to do, before I leave this, I talk about get hands-on experience the next 12 to 24 months. I see people that do BSc, they don't have the project they did in their BSc, they're not working on it to get it published. Some have finished masters, what they did in their masters, they're not working on it to get it published. So when are you going to polish your skill? You should polish your skill right from your BSc. When you do your project work, try to see how you can write out the manuscript. You learn. So apart from this, build core competencies. Strengthen fundamentals in at least one programming language and one bioinformatics toolset. Complete a project that integrates lab data with computational analysis. Then, apart from this, expand your network. Attend a conference or webinar series in your chosen area. Reach out to potential mentors with specific questions. Then, apart from this, plan your next steps. Outline graduate school, internships, or industry roles that align with your interests. Set measurable goals and timelines. If what your goal cannot be actualized around you, then you should go far. And the internet is helping you today. Okay, Eniola, bye-bye. Bye-bye, Eniola. But I'm still here. I'm trying to round up now. The internet is there to help you. So if what you actually want to learn is not very close to you, what you should do is that you should then communicate with people that are doing those things by email. Check their website. There are courses online you can take and still grab the understanding. Now, I am doing this live stream and you are there. You are getting value. It's not a mod that will be in a particular classroom and be speaking. This live stream is a means of communication. If you are in the same class with me and I'm talking to you, it's still the same voice, the same way I'm going to be telling you. So what you should do is that if what you want to learn is far away, try to learn it online or try to see if you can get the resources to travel and go and see and use those materials and those equipment and those information. Microbiology sits at the heart of solutions to some of humanity's most pressing problems. I'm already concluding. For young microbiologists, the present is rich with opportunity and the future promises even greater scope for impact. So you have to stay curious, be courageous in exploring new methods, and cultivate the interdisciplinary skills that will let you translate microbial knowledge into real-world benefits. So this is where I'm going to stop now on this subject matter of opportunities for you as an individual that is into microbiology and you want to extend and you want to expand. So the field is vast, the opportunities are there, and these are some of the opportunities ahead for young microbiologists, the present realities and the future pathways. So I have laid everything before you in this live stream. I believe that you have gained much value. So around this time tomorrow again, I'll be live again talking about another subject matter as related to microbiology. Please subscribe to this channel, like this video, share link of this video with your family and friends, and check my YouTube channel, Master Microbiology, for other content that I've done talking and relating to microbiology that are going to help you. So every day like this, I'll be live and direct around this same time. I'll see you tomorrow. Bye-bye and have a good one.